Polar plot is one of the important open loop frequency response plots. Now, like bode plot, we have to take the open loop transfer function and give the sinusoidal input to that and get the response of the system. So, in open loop frequency response, we can find out the gain margin and phase margin so that we can find out the stability of the system. So, to find the gain margin, phase margin, which are the relative stability margins, and also to find the closed loop system stability, we use polar plot. Polar plot is generally plot on polar graph sheet. The polar graph sheet looks like this. Now, in this polar graph sheet, we have x-axis and y-axis. They are the major axis, you can say. Now, this is in this particular plot, we have phase angles. So, from center to all the radial lines indicate the phase angle, which means from center the right side, let us say it is a positive real in S-plane, so that is the zero angle. And from zero angle, when you measure in counterclockwise direction or anti-clockwise direction, then you will get all positive values. Then if you go in this direction, clockwise direction, then the angles will be negative. So, positive angles always represent the anti-clockwise direction, negative angles means clockwise direction. So, when I start here 0 degrees, when I go in this direction and this line is going to be minus 90 degrees and this is your minus 180 degrees and this is your minus 270 degrees and so on. So, like this you can have the cycle. Now, if you go in other direction, counterclockwise direction, 0 degrees, then it is going to be plus 90 and plus 180, plus 270, again we have plus 360 likewise. Now, so if I say minus 90, which is equivalent to plus 270, and if at all if you have minus 270, that is similar to your plus 90, and this end we have plus 180, minus 180, both are same. So, in between what are the lines we have, those lines indicate the phase angles. Now, when you look at the circles, the radius of each circle gives the magnitude. Let us say from origin to this it is 0.2, the radius is 0.2, which means this particular the point on this circle is the magnitude is 0.2. So, similarly I can draw all the circles which gives each radius. Now, when I locate a point in this graph, when I locate a point, it has got two coordinates. What will be the first coordinate? It is the radial distance from the origin, that is the magnitude, and from 0 degrees to that point, what will be the angle? Therefore, each and every point when you locate on this polar plot, so that gives the magnitude and phase angle at one particular frequency. We don't have frequency axis in this case as like your bode plot. When you look at the bode plot, we have frequency axis, I have magnitude, therefore separate magnitude plot, separate phase plot, and we are going to combine these two and we are going to plot in a polar graph sheet, which is called polar plot. So, this polar plot is mainly used to find the closed loop system stability by looking at the magnitude and as well as the phase angles. Let us look at one problem and see how can you solve, how can you plot the polar plot on a polar graph sheet. Now, the problem statement goes like this. Draw the polar plot for the system whose open loop transfer function is given by gh of s is equal to 1 over s into s plus 1 into s plus 2. So, open loop transfer function is given. As we know that polar plot is drawn for open loop transfer function. So, open loop transfer function is directly available. So, from this we can start. So, in polar plot we have two things. One is magnitude and phase angle. Therefore, when you are going to plot the polar plot, take the open loop transfer function and get the sinusoidal transfer function by substituting s is equal to j omega, write the magnitude and phase angle expressions, and for different values of omega, then we can tabulate the magnitude and phase angle, then we can locate on the polar plot, complete polar plot, and when you join the point, that will be the open loop frequency response or polar plot of the open loop transfer function. Now, so for this transfer function, I am substituting s is equal to j omega. Therefore, j omega is nothing but 1 divided by j omega, 1 plus j omega, 2 plus j omega. So what is the magnitude expression? Magnitude numerator is 1, in the denominator we have j omega is omega, then it is under root 1 plus omega square and it is under root 4 plus omega square. So this is the magnitude expression. Then what will be the phase angle? Phase angle is numerator is constant, therefore 0. Then denominator for 1 j omega it is minus 90, then minus tan inverse omega minus tan inverse omega by 2. So magnitude and phase angle expressions. Once you have these two, then I am going to prepare a table like this. So in this table, the first column is omega, then next is magnitude and next is phase angle. Now, so we'll start with omega 0, which is the starting point. So when omega is 0 in this particular problem, when you substitute those two equations, magnitude and phase angle, you will be getting magnitude it as infinity and the phase angle is minus 90 degrees. So this infinity is the starting magnitude and minus 90 is the starting phase angle of the polar plot. So any plot will start some point. So that point we are directly getting when you substitute omega is 0. For various values of omegas, then we can calculate magnitudes and we can calculate phase angles. Now when you calculate, if you look at the table, I am interested on these 2 points where 4.96 and 0.86. So in between the magnitude is decreasing from 4.86 to 0.8. So we have 1 around it. So magnitude 1 is one of the very important points. So around that one we should take more number of values and corresponding omega also very important. Similarly, when you look at the phase angle is varying from minus 90, it is keep on increasing. So when it is increasing, I am interested to look at it minus 161 and also minus 880. So in between we have minus 180 degrees. So minus 180 degrees again one of the important point in the all phase angles. What will be the corresponding frequency? So when you exactly calculate for magnitude 1 the frequency, that frequency directly I can say it is the gain crossover frequency. We know the definition of gain crossover frequency. It is the frequency at which magnitude is unity. That we will be getting directly. Similarly, at 180 degrees, if you calculate exactly what will be the omega while tabulating, that omega is called omega PC, which means phase crossover frequency. We know the definition of it. It is the frequency at which the phase angle of GH of j omega is going to be minus 180 degrees. So if you increase the omega values, and the second table we can increase like this and we can go up to infinity. So when it is infinity, it is going to be minus 270 degrees phase angle and the magnitude is 0. So infinity is the ending point of polar plot, then 0 is the ending magnitude and minus 270 is the ending phase angle. Ending phase angle is minus 270, ending magnitude is 0. So from this entire table, the starting and ending are which are very important when you look at only those two. So omega is 0, magnitude is infinity and phase angle is minus 90. When omega is infinity, then magnitude is 0, the phase angle is minus 270 degrees. In between there are many values. Now take the polar graph sheet and look at this polar graph sheet which I have. Then you choose the circles with the proper measurements. And as well as we have phase angles. Phase angles are directly available in the polar plot. Only thing is the magnitude we have to choose properly. Then this is 0 degrees and this is minus 90 degrees. This is minus 180, minus 270. So we know that the starting point is minus 90 degree angle. The magnitude is infinity. So in this graph we cannot locate the magnitude, but we can assume, we can easily predict from which area the polar plot is starting. When the polar plot is starting, it is coming from minus 90 degrees. Therefore, I have minus 90 degrees. Let us say here assume omega is infinity, magnitude is infinity. Then this is starting point and the ending point is magnitude is 0 at origin. But while it is approaching to 0, at what angle it is approaching, that is very important, which is the ending angle. So minus 270. So when it is approaching to 0, so it is going through the minus 270. In between all the values we have. So you just draw the smooth curve which is the polar plot of the given open loop transfer function.